All right, we'll start in a little bit. It's still early, but let's wait for more folks to show up. So we will start probably in about 5 minutes or so.
I can hear me.
I know, I need to lower this.
All right, well, why don't we get started? How many do we have here? 17. Okay, we added a couple more. All right. Well, thanks everybody for attending. I'm assuming everybody has the audio and video is working. If you have any issues, type them into the chat. Also, write my questions. You can type into the chat, and then we'll try to answer those. Although we can do questions afterwards. Okay. All right. So I think you can see the main slide, right? I think. Okay. Very good. So the purpose of this meeting is to talk about the newly approved Bachelor of Science in Aerospace Engineering, and there'll be other discussions about this. This'll, I mean, we can't just cover this completely in a half hour, but this will be one of the first ones kind of to give an information of what the program is, some of the logistical issues, and so on and so forth. And also, again, just to start the dialogue where you can ask questions and we can start to make it clear to everybody. Next slide. I guess I do this, right? Okay. So here we go. So the department has, I think most people have realized that we've had a very strong focus on aerospace engineering for quite some time now. A significant number of our students, some years, almost 40% of the students that graduated have gone into aerospace engineering workforce. And so we felt it's really appropriate at this time that the department, have a Bachelor of Science in Aerospace Engineering, and that'll help give more options for you all and future students, and hopefully, serve your needs for what you want to do with regard to the rest of your life and education better. All right. So today, what are we going to talk about? Let's see if this will. Okay. First, we'll get to talk about the degree plan and all these issues, but really I think there's probably, it wouldn't be a bad idea to talk a little bit about what aerospace engineering is and where it is in relationship to mechanical engineering, right? Particularly. Then we'll talk a little bit about how the overall program is organized, what its educational objectives are. Then we'll look at the degree plan and see how that works. And I'm calling this just, like, should I change my major? But, there's some pretty common questions that come up about, dual degrees, should I change my major? I'm graduating this semester, and we can try to talk about those. And then at the end, we'll do open up the floor for questions and answers. Okay. All right. All right. So what is it that aerospace engineers do? And so, of course, this is, there's no way I can do this in one slide, right? But this is assuming that you have a reasonable idea about what mechanical engineers do, since you're all mechanical engineering majors, I think. We can use that as a point of departure, right? So it's very similar, obviously. So some of the fundamental engineering science is identical, but it's just really on the point of application. So obviously, aerospace engineers design systems that go in the air and go into space, right? And this is kind of the point. So historically, these have been aircraft, commercial, military, spacecraft, again, commercial, military, satellites, some weapon systems, missiles, anti-missile systems, defense systems, this sort of stuff, okay? But there's also crossover into other areas as well. Now, I think everyone's pretty aware of a lot of the news stories that's been going on with Virgin Galactic launches, SpaceX, Blue Origin, this whole concept of commercialization of space has really opened up other areas where smaller companies have been involved. So there's a lot. I think it really is an amazing time to be in this area. Arguably, even more exciting time to think about aerospace engineering than back in the 60s when there was the Apollo and Mercury missions going on, right? And that's because there's just so much work that has to happen, and it's going to happen. It's going to happen not in my lifetime, but very likely in your lifetimes. Okay, so autonomous systems, right? This is a big deal. Obviously, this has overlap outside of aerospace, but aerospace is very interested in autonomous. Commercial space, all the systems that are needed to support commercial space activities, operations on the moon and asteroids and cislunar and Mars and beyond, right? Systems engineering, digital engineering, these are all things that have been started in the aerospace sector, but have now translated into all other areas of engineering. But at their heart, they really did start in aerospace. Okay. So historically, again, you know, large companies have the capital to develop these often expensive aerospace systems. Also government entities like NASA. You can be civilian government worker in NASA, or honestly also in the DoD branches. Air Force and Navy also hires aerospace engineers. So that's classically where this has been, right? Manufacturing, analysis, design, systems integration, test deployment, those sorts of things in the government, right? Whether it's, you know, on the systems procurement side or the systems development side, right? But again, also, you know, as we move into these other opportunities, there's a lot more, the playing field has grown for smaller companies to be involved. I mean, there have always been smaller companies that have been involved as second and third tier contractors, subcontractors, right? But now you can see that, you know, companies like SpaceX, Blue Origin, and whatnot are becoming, you know, involved in this area now. Okay, and that's changing a bit. This classic paradigm of that, like every aerospace engineers are going to go work at Northrop Grumman, right? Okay. So again, this is changing. So okay, why would you pursue aerospace versus mechanical? Why do we have one and not the other? Why do we have both, right? So you still have to remember that the aerospace industry primarily employs mechanical and electrical engineers, still to this day. The number of aerospace engineers that are employed in the aerospace sector is fewer. There's not as many. Mechanical engineering, actually, if you take all engineering disciplines besides mechanical engineering and you add up the number of graduates a year, it's approximately equal to the number of mechanical engineering graduates a year. Mechanical engineering is the most broad field out of all engineering disciplines, and that's reflected in the number of, you know, BSAE degrees that are conferred every year in this country. So like I said, that number is equal to every other degree added up. Civil, electrical, systems, industrial, computer science, all those things added together, all right? And aero, right? So it's a much smaller discipline. But honestly, most of the academic work is still very much the same. We're applying engineering, physics, mechanics, whether they're structural mechanics, thermofluidic mechanics, but they're being applied onto aerospace systems, not so much mechanical engineering systems, right? So for example, if you talk about fluid flow in a mechanical engineering curriculum, there's a heavy emphasis on internal flows because mechanical engineers deal a lot with internal flow systems like flow through pipes, flow as it goes into a generator section or a compressor section or expander section for a power system, or whether it's a combustion engine or a Rankine cycle for a steam power plant, right? Aerospace engineers have to deal with that as well, especially on the propulsion side, but much more often they have to deal with external flows. So flows around a body, obviously, you can see where this is going with development of aircraft and lift and drag and control surfaces and stability and those sorts of things. And actually, you know, yes, it's still all fluid mechanics, but there are different sort of methods with dealing with external flows than with internal flows. And like if you look at the topics we cover in the mechanical engineering fluid mechanics course, they're going to be a little different than the ones that will be covered in an aerospace fluid dynamics course, okay? All right. So what does that mean as far as what you work on, right? Because I already mentioned that still, even in the aerospace industry, we have majority of mechanical engineers being hired, right? Well, this is a very much my opinion, rule of thumb, and so don't take this as gospel, but I mean, in general, in the writ large context, right? Degree aerospace engineers will tend to be involved in the projects that really involve those aerospace engineering aspects. So when it comes to doing the overall aircraft design, that's systems engineering, right? Designing the space system itself, right? That sort of stuff, you'll tend to have a little bit more presence of aerospace engineers. When you do the detailed design, right? If you're doing a landing gear, you know, a mechanical engineer can function as well as an aerospace engineer in designing a landing gear. And in fact, when you start as a new graduate, you'll be designing those subsystems anyway. So most likely, you'll be working very strongly with a mechanical engineer anyway, or groups of those, right? Okay, mechanical engineers work in aerospace, aerospace engineers work in mechanical. There's obviously less crossover of aero into mechanical, but more and more there's non-aero fields that aerospace engineers are going into. Like again, because aerospace engineers historically have a stronger emphasis on systems engineering and also on controls, that you'll see companies like Uber and Tesla are hiring aerospace engineers, Microsoft, because of the projects that they're interested in. They're not interested in making aircraft. Well, some are, but you know what I mean, right? But they sometimes view that skill set as being critical. But those types of crossover jobs will almost always, I've never seen one that says only considering aerospace engineers. They will always say, mechanical, civil, electric, and they'll have the big range. Do you know what I mean? But aerospace engineers are starting to work in other areas. Okay. All right. Job market. And if you guys have any questions on this, just type them into the chat. I will try to respond. Okay. As I see it, because I'm looking at that, I can see the chat right now. So if you put in questions, I'll answer them as I'm going through the slides. And as well, we'll do questions at the end. Okay. All right. So as far as the aerospace engineering job market, right? So the median annual wage, this is all aerospace engineers, old people like me, as opposed to new graduates. Everybody all take their average salary. It's $118,000 a year. Okay, that's what it was about a year ago. Mechanical engineering, the average is 90. So there's a bump. So that's a pretty reasonable bump. I'll take another, $28,000 a year, right? I'll do that. That's good. But again, this is an average, right? And so sometimes these things, for mechanical engineers, I believe that number is probably pretty strong because there's so many mechanical engineers. But aerospace is the way BLS, Bureau of Labor Statistics, kind of does some of this math. They only look at certain categories, and historically they are missing stuff in the aerospace analysis. So that may be biased, but that is what's reported by the Bureau of Labor Statistics. Okay. All right. It's predicted to grow 8% over the next decade. That's a pretty average growth. I think that is one of the things that BLS is getting low, because when I do talk to people in the industry, they say they are hiring at rates that they haven't before. This has to do with the fact that government spending has gone into defense systems, so that market is bumped. And they believe that this is not capturing any of the growth in the commercial space sector. And it's definitely not capturing any of that sort of tangential growth, like, when Uber wants to design autonomous aircraft, to consider this as a transportation option for Los Angeles or Southern California, right? That doesn't get captured at all. So I really think that actually that 8% is low. I think it's actually higher growth, okay? But again, that's my opinion, okay? But the downside is that historically this industry has been amazingly cyclical. The joke was always like, An aerospace engineer spends half his life being hired and the other half of his life being fired, right? There's always there have always been these big 5-year sort of cyclical phases of boom and bust. I do think that has leveled off. When I was a practicing engineer back in the 90s, it was definitely an issue. You know what I mean, right? It was sort of feast or famine, and then it was just what it was. And you would see the same people at different companies. You know what I mean? But I think it's stabilized a bit, so that's a good thing. But as opposed to mechanical engineering, where there's always mechanical engineering jobs, right? Okay, the number of just as a reference, I think if you look at like Glassdoor or something like that. I'm going to forget where I've seen the number, but basically, people have done studies where they look at the number of relevant job opportunities a mechanical engineer could see in their lifetime, as opposed to an aerospace engineer. It's like an order of magnitude more because there are just that many more mechanical engineering positions than aerospace. But again, of course, there's nothing that prevents an aerospace engineer from working at General Motors, you know? So. And for us, right, typically we've always had a high placement into that area, okay? There's another thing with aerospace engineering, it has a geographic kind of effect. So here you can see the darker the green, the more aerospace engineering jobs there are. So you can see Texas is very strong, and that makes sense because we have Lockheed in Dallas area. In the Houston area, we have Boeing and the folks supporting NASA in that area, right? California obviously has always been a hub. Washington, because you have Boeing in Seattle, right? The Southeast has now also emerged because Lockheed, Northrop Grumman have assembly plants out there. And then historically, actually, even in the Northeast, the aerospace industry started out in Long Island, and grew from there, really. So, yeah, so you can see that there is definitely some pockets of concentration, if that's important to some folks, All right. So are there any questions on what it means to be an aerospace engineer before I move on to the program itself? If you want to ask it on a mic, you can unmic yourself and ask a question as well, okay? I think you guys are pretty respectful. I don't have to. There's only 20 of you anyway, so.
No, sir, no questions.
Okay. Okay, so let's talk about the program itself then, okay? All right, so one thing I guess I should mention, which I didn't put on here, but I guess we should be aware of this, right? All the courses are going to be designated as Aero, A-E-R-O, right? Not to be confused with Aerospace Sciences, A-S. Aerospace Sciences exists at this university. It's existed for quite some time. It's completely different. It has nothing to do with aerospace engineering, okay? It has to deal with, that's really a ROTC program, right? So those courses, the AS courses, is not what we're talking about. We're talking about courses moving forward that will be designated as Aero, okay? So, the program has elements of the classical legs of aerospace engineering, aerodynamics, propulsion structures, and then dynamics controls. But since we're a newer program, we've also tried to add an emphasis onto some of these more emerging areas. So give students opportunities to have exposure to commercial space. Autonomy and machine learning is becoming ever more important fact in aerospace systems. Hypersonics, digital engineering, small sats, and also even we think that over time we'll have an aspect of human existence in space. So whether it's habitat, physiology, that sort of stuff, which you won't see necessarily in other more classic aerospace programs. But these are really what we feel are things that are going to be critical moving forward for y'all. Okay. So the first 2 years of the curriculum is, with the exception of the materials class, is identical to the BSME program. So the freshman and sophomore years are the same. The freshman year is identical. The sophomore year, with the exception of the materials class and lab, is identical. And that's for two reasons, right? One is obviously, as I stated before, there is a lot of overlap. And so we don't need to really have a different statics class for aerospace than we do for mechanical engineering. It's basically the same, all right? The other reason for having the common 2 years is that then it gives you all a good amount of flexibility as to like, hey, I don't know if I want to do this or that, and you don't have to make the decision as a freshman. If you decide, I mean, honestly, even going into your going into your junior year, that you want to do aerospace, or if you were aerospace, you want to do mechanical, whatever it is, you can do that without really having any significant impact on your time to graduation, I think. Okay, so that's the two reasons. Okay. Okay, what's going on next? All right, it's same number of credit hours, 128. Again, as I said before, first 2 years are the same. There are required classes that start in the junior year. There is a materials class in the sophomore year. And then to keep it somewhat flexible, we've identified concentration areas or theme areas. There are 4 of them. They're listed here. Okay. And what the degree requirements are now is that you have 5 classes that can come from these concentrations, so to speak, right? 3 of them, you pick a concentration and that's what you do it in. And then the other 2 have to be from different areas, right? So that means that by definition, you'll have 3 of the 4 in your concentration area. But of course, that doesn't mean you don't see any systems or any controls. There's a required controls class, there's a required systems class in the degree plan, okay? It's just a matter of like, hey, I really want to do propulsion, or I really want to look at aerodynamics, or I want to do structures. Does that make sense? You know? And so that's the idea. All right, here's the degree plan. We put it in the same format as the ME degree plan because I hope that most of you are familiar with that and get the logistics of that. Here's the first year, which could have been the first year of mechanical. It's identical. It's no different. It's exactly the same. The second year, in this case here, there is an aerospace materials and an aerospace materials laboratory. So that replaces the mechanical engineering materials class. And the idea there is that there's a more heavy dependence on, yes, there's alloyed metals, but also composite materials, ceramics, and not necessarily on the material science of the alloying of these things, but really them as far as component selection. So fatigue issues, material selection with regard to design and whatnot will be covered in those, okay? But they'll be, there will still be crossover as well. In the third year is where we start to see a bit of this differentiation. This is the junior year, right? So you can see in here we have some required classes, an aerodynamics class, a structures class, and a controls class, right? So aerodynamics, again, like I said before, that's going to be in lieu of the fluid mechanics class. And again, there's more emphasis on aerodynamics. The structures class is in lieu of some like the principles of design. The focus here is more on analyzing aerospace type structures because there are different concepts that have to go into that. And the controls, again, kind of, I think this replaces the mechatronics class, I think. You can think of it that way. But again, it's, dealing with an ungrounded body, the dynamics controls of that are in a lot of ways very different than dealing with like a grounded robotic arm. So it's something free to move in space. There's other stability conditions on there. So there's a little bit of a difference in there, okay? I think our mechatronics class is a little bit more applied in the mechanical, whereas in dynamics controls for aerospace will be a bit more theoretical based on transfer functions, stability analysis, these sorts of things. Will thermodynamics or fluid mechanics transfer over for aerodynamics? No, they will not. They will not. Because, and yeah. And then we start to see the concentration. So you can take your first concentration at this point. Again, you can think of all these things as free electives, whether that first class in your spring semester, junior year is in your concentration or it's in one of the free areas. It's really, you're not declaring at that point in time. It's just, at the end of when you come to graduate, that you have those boxes checked off, right? So then in the senior year, we got more concentration. I don't know why propulsion kicked off, right? That's just hiring. So we have, can I do a little pointer here? I think I got a pointer here somewhere. Cursor, I got a cursor. Whoops, that didn't do it. Right, so I think I can write on this. You have a concentration here. Oh, maybe I can't. I don't remember. It's not letting me do it. Okay, whatever. So you have, let's just highlight everything. So these are the ones that are aerospace classes, right? So you have a 2 and 3, the second and third in the concentration area, and then you have 2 free electives, which will be out of the concentration area, right? You can't do 4 in the concentration area. And in those free electives, they need to be in different areas, okay? So you can't pick 3 in propulsion and then 2 in structures. You have to do 3 in propulsion and aerodynamics, and then 1 in structures and 1 in controls or something like that, okay? All right. And then, of course, required, you have to learn how to design aircraft. You have to learn how to design spacecraft, right? So that's in here. And then you have a senior design experience, much like we have in mechanical engineering, but obviously the things that you'll be designing are different, right? And I think that's kind of it for the degree plan. Oh, here's some example concentrations. Here's some, here's these might change in time, right? Like I think we're going to add some aspects of digital engineering and hypersonics pretty quickly, but yeah, that's what they are now. Well, laboratory experience, when you see the full degree plan, the laboratory experience is their labs. So there's a list of labs, much like it's the same as on the newer mechanical engineering degree plan, where you have a choice of different labs that you can take. Okay. So I didn't list those here, but they're on the full documented degree plan on the back page. Okay. I think. No, we don't have a slide on that one, but yeah. All right. Well, here are the 2 degree plans. This is a little tough to see, but you can stand them next together and you can see that there's a lot of crossover. Okay. All right. So this will start in the spring. Okay. There's always going to be transition, so this will be a little, it'll be a little bit messy. Once we hit steady state, I think we won't be in such a situation. Last semester, we offered an aerospace structures class, actually, even though it was a mechanical tech elective, but it would have counted as well. But in the spring, we'll be offering the following courses as dedicated aero courses. And so these are on the degree plan. All right. So we'll have the materials course. We'll do the aerodynamics. We'll have the dynamics controls class. And then we'll also do an elective, a senior elective in structural dynamics. Right. So we have the sophomore level class, so that serves the sophomores. Then we tried to start getting into the required classes for the junior level. And then we also did one concentration class. These will increase, but we're using the spring semester as a bit of an indicator of how many students are going to be enrolled in the program, and then obviously how we deploy the classes is a function of that as well. Okay, these classes will also be open to mechanical engineers. Mechanical engineering students can take these as technical electives, right? All right, that's pretty much it. So let me just do some common questions, okay? So, okay, yes, I want to move into aerospace. Well, this is basically just a change of major, okay? So you can do the change of major form. It's in the system, and so you can declare aerospace as your major. You can do that today, okay? You actually could have done that back in August, and sooner, but there was a little bit of an issue with regard to financial aid. So we had to get, you have to formally push some papers to the Department of Education to make a new program be recognized as being approved for students in that program to receive financial aid. So up until about 2 weeks ago, that was not the case. So we didn't really want to push people into the program and then find out that they weren't eligible for financial aid. But now at this point, if you're in the aerospace program, you're eligible to receive Pell Grants and financial aid, okay? All right, so I'm a senior in mechanical engineering. I want to be an aerospace major. Can I do this? Well, the short answer is yes, you can. The long answer is though that I think probably you'll delay your time to graduation by at least a year, maybe a year and a half. And you have to really think seriously about, is that something that you want to do? What's the benefit for you? I already mentioned that we have no issue now with our graduates going into that area. If you're going to spend another year and a half, maybe it might make sense to pursue a master's degree where your thesis topic is in the demonstrable aerospace, scheme of things, right? And then you can market that, and it might actually be more effective. My personal opinion, that's probably a more effective route. Okay, but again, that's my opinion. That's not fact, right? Other people will have different opinions, but in my sense, I think that's true. I mean, if you were saying, hey, I'm a psychology major and I want to work in aerospace, then yeah, you probably should just change major and then just eat the fact that you're going to spend another 3 years, okay? But anyway, can you double major? Well, you can double major, okay? And I think that would add probably at least a year and a half on, okay? But again, I question as to why. Do you know what I mean, right? I personally think that if you spent that time getting a master's degree, I think you would be better served by that. Typically, companies that have their starting salaries binned by the applicants, right? Like Lockheed Martin or NASA. If you have 2 bachelor's BS degrees, I don't think you don't get any bump in pay. If you have a graduate degree, you get a bump in pay. Someone with a master's degree will get at a higher pay grade than someone with a BS degree. So, again, I think honestly the master's degree is more edifying in that sense. So I wonder about that. You know what I mean, right? Okay. There's not going to be a minor in aerospace engineering. We don't have a minor in mechanical engineering. We don't have a minor in aerospace engineering. We don't have minors. I do think, though, that at some point in time, we might have some certificates because they're relatively easy to do and administer. And then I think that would give students a mechanism to kind of say, hey, I'm a mechanical engineer, but I also took a couple of aero classes, right? Or vice versa, right? And all right. What if you're a mechanical engineer? You decide to stay in mechanical engineering, but you want to take, aerodynamics. Can you take it? Well, yeah, you can take it, and they will take those as technical electives, okay? And we'll also add some of them into the tracks, the proved tracks in the mechanical engineering degree plan, okay? So I expect that in the aero classes, there will be a considerable number of mechanical engineers, okay? And do I have another one? Oh, that's it. Okay, so that's the end. Questions? Very quiet audience.
Yes, sir. No, I have a question to confirm or like reaffirm. So there is a program for aerospace to get a master's then at UTEP?
Not currently. We expect that we're planning on having one next fall.
Next fall. Because I'm a
I
junior.
can't guarantee that,
I'm a
but I
junior.
say that. So let me just clarify that, okay? So we're writing the proposal now, which means it should be on track to get to the state and get approved over the summer. But that's out of my control. You know what I mean, right? The provost could choose not to sign it. The Board of Regents could choose not to sign it or approve it. THECB, the Texas Higher Ed Coordinating Board, could also choose not to approve it. I really don't think that would happen at any of those levels, but I can't guarantee it. You know, it's out of my control in a sense, but we are trying to do that for next fall.
Yeah, okay, I understand. Thank you, sir. And then, but does UT have a master's for mechanical?
Yes, we have a master's in mechanical engineering and a PhD in mechanical engineering as well.
So
And you can
technically,
start the PhD program right out of your BS as well. Yes.
Oh, okay. How much is that? Is that another 4 years?
For a PhD or master's?
Yeah. For PhD.
PhD, 4 to 5 years probably. 4 years is probably a reasonable estimate. Our program tends to graduate relatively quickly in the PhD program. It's about 4.
Oh, okay. Alrighty. All right. Thank you, sir. Appreciate it.
But it's not fixed. It's not a fixed amount. You know what I mean, right?
Yeah.
There's an issue of that your advisor and your thesis committee feel that there's enough work done. It's not like, hey, I took these classes, give me a PhD. It's a little different. So yeah, but about 4 years. Yeah.
Oh, okay. Thank you, sir.
Okay. So yeah, excellent question. The question is, I plan to take technical electives in the spring. How will we know what classes will be considered as technical electives? Okay. So we're doing the spring schedule now. So that's why I can say what those classes were for the Aero program that are going in there, that'll be offered, right? And then when we get into advising, right, which is I think usually in October, right? We do advising for the spring at that point in time. Normally, right, we do the advising, it's kind of online because everybody knows the deal, right? Mechanical, so it's easy. We will have more communications about the offerings. We'll have more sessions. And then I believe we will also try to organize some more like one-on-one-ish type of opportunities where we can sort of look at your degree plan and judge, give you a bit more accurate assessment as to what would be the ramifications of changing major and whatnot. Does that answer your question, Zahid? Wait, I think so. Okay. If not, chime in or text again, okay? All right, the second question is, okay, I'm changing my major from chemistry to aerospace. Could chemistry be used as the science? Yes, they can. Yeah, without a doubt. Yeah. So I don't know. I mean, obviously we require chemistry 1, I believe. And then there's do we have, oh wait, no, that's a good question. I have to go back and look. Do we have the math science elective in here? Yeah, so you see we have a math science elective down here in the junior year. And that's a lab class, I think. No, that's not a lab class. It's a non-lab class. So if you took chemistry 2 or something like that, or organic chemistry, that could count towards that, yes. Well, okay, so if you decide to double major, if you want to do the double major, then obviously the courses that are common, you only have to take once. You don't have to take statics twice, one to count towards mechanical and one to count to aero. All your state core, you only take once, right? But the ones that are different, those are the ones that you'll have to take in both, right? So you can count them up, right? We could probably have a little discussion on the electives, but basically you're talking about 1, 2, 3, 4, 5, 6, 7, 8. So 8, 9 additional classes. Does that make sense? Something on that order. We'll try to more firmly map that out and make some material that clearly illustrates that, like what would count towards both. Does that make sense? But I have to apologize. I don't have that ready right now. But we'll have that ready before advising for the spring. Okay. But that's basically where we're going to be at. Okay. Any other questions?
I have a question about we have to take statics and then aerostatics. Could be two different types.
No, 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 there's no aerostatics. There's aerospace structures. But there's no aerospace
Okay.
statics.
And then if I took statics, like I'm taking statics right now. So
If you
I'm
took
taking
statics,
different
if you took statics, that counts as statics in the aerospace degree. That's the same. If you took mechanics materials, that counts. If you took, let's go back to the, oops. Most that's here this year too. So mechanics and materials, same class. Dynamics, same class. Intro to thermal fluid science, same class. Engineering computations, same class. Electromechanical systems, same class. Yeah, it's the same class. And freshman year, it's the same deal. Let's see if we can get back in. Where's year one? Year one, graphics, same class. We don't have an aerospace graphics. Statics, it's the same course. We don't have air. There's not a separate aerospace statics. And I guess that's it. Yeah. Yeah. Does that make sense?
Yes, sir. Thank you for clearing that up.
So actually, you'll see the ones that is, you can see it's mech, right? So those are right. That's the same that that's in the mechanical, the mech ones, right? The only ones that are different. You see, like we've got aerospace materials here. That's going to be designated as aero, not mech. And there will still be a mech. I think it is 2331. Okay. No, the labs for chemistry and physics do not count as laboratory experience because those are like, that laboratory experience is like thermal fluids lab, solid mechanics lab. Does that make sense? Their labs very much associated with aerospace engineering and mechanical engineering. No, and analysis and differential equations are different. So here you can see year two on this slot here. I don't know why this cursor thing doesn't work, right? But there's differential equations. You can see it's the last slot on the spring semester. And then I don't have this memorized yet, but is. And then we have engineering analysis here as well. Okay, so there are two different classes, as it is on the mechanical engineering degree plan as well. But it's analysis too, right? Oh, you're on the previous mechanical engineering plan. So I can't, I need to know exactly what degree plan you're talking about before I can answer that question. Okay, you have to give me the year because there's more than there's like three actually. Okay, technically. Okay, but that sounds like a mechanical engineering question. Does that make sense? We can do that offline if you want. Any other questions? Going once? Going twice? All right. Well. Thanks again. We're very excited about this program. I know the students are very excited about this program as well. I think again, it'll just make it a stronger program for both mechanical and aerospace. We will be sending more material out this to help with some of these decisions that I know there's still going to be questions and everyone's going to still have unique cases that we'll have to deal with. And so we'll try to have sufficient sessions that are sort of face-to-face, not like this, but ones where you could actually bring your degree plan and we could actually sit down with advisors and say, okay, this is the deal. Okay, does that make sense? And I think that will happen going into the registration period for the spring. Any other questions? Oh, wait, we got one. Nope, that's just the thank you. Okay. All right. Well, if not, thanks again, and have a good rest of your afternoon. Okay. Bye-bye.